Today's learning target is I can write rational numbers as fractions and identify and classify rational numbers. Rational numbers are any numbers that can be written as a fraction. So all four of these numbers can be written as fractions. Now, you're probably pretty familiar with these. We're going to take a look a little later at how do we write a repeating decimal as a fraction. If we need to write a rational number as a fraction, there's two examples here. Let's take a look at B here. So if we needed to write negative 23 as a fraction, you can see here they've done that, and that's fairly simple. All you have to do is put over 1. So it's negative 23 over 1 would be the same as negative 23, because really what this is saying is negative 23 wholes. Okay, because this would mean it's wholes. Or you could write the negative sign here too. If we have a mixed number like letter A here, 6 and 1/6, okay, you can see they've given us the answer, and the answer here as a fraction is 37/6. Now, to get that, remember the way to do that is you do this. You take your denominator and you times it by the whole number. Okay, so in this case, it's 6 times 6 is 36, and then you add the numerator, plus one more would be 37/6. Now the reason this works is because we want to get the fraction into sixths, or the mixed number into sixths. And so I have 6 holes, and there's 6 sixths in one hole. So I have 6 groups of 6. Okay, so that's why I take 6 times 6. So 6 groups of 6 would give me 36 sixths. Plus, there's one more sixth in the numerator. So 36 sixths plus one more 6 would equal 37 sixths. If we're asked to write a decimal as a fraction in simplest form, okay, so in this case 64 hundredths, and we want to write that in a fraction as in simplest form, first thing we need to do is we need to write that 64 hundredths as a decimal into a fraction. Now we want to simplify or reduce this fraction, and we do that by finding a number that I can divide into both the numerator, the top number, and the denominator, the bottom number. Now when I look at this, right off the bat it jumps off to me they're even, so I know that 2 will go into both of those. And when I do that, then I'm left with 32/50ths. And I see that those are both even, and I know anytime I have a number that's even, I can divide by 2, and that leaves me with 16/25ths. Now, there's no more numbers that'll go into the numerator, the top number here, or the denominator, the bottom number here. Okay, the only numbers that would go into 16 are 1, 2, 4, 8, and 16. And the only number of these that'll go into this is 1, so it's in simplest form. So 16/25ths. Now you can see that up here they divided each by 4 right here, and if you found that the bigger the number you find, the fewer steps. I just took the evens or divided by 2 because I saw they were both evens, and that was quicker for me. However, the larger number you divide by, the fewer times you'll need to divide. In this problem it says a handheld video game system weighs 9 and 675 thousandths ounces. Write this decimal as a mixed number in simplest form. So again, the first thing I want to do is write the decimal number as a fraction. So I have 9, and then there's a decimal right after the 9 there. Okay, and that's the part where my fraction is going to begin. So then I'm left with 675, and you can use this chart here, and you can see how they got to thousandths, and they know that one was when it's three places to the right of the decimal, it's thousandths. So 675, and because I say it thousandths, that would be what my denominator is. Okay, if it was just one decimal over, it would be 6/10. I'd write it like this. If it was 2 decimal places over, it would be 600ths. I'd write it like this. Okay. When I look at these two numbers, the numerator and denominator, I see that the numerator ends in 5 and this ends in 0. So I could divide each of these by 5. But remember, the larger the number I divide by, the fewer times I have to divide. So I also see that 25 would go into each of these. So if I do some mental math, I know 25 goes into 104 times, so it would go into 1,040 times. Now to do 675 divided by 25, maybe you do that in your head. Maybe you say, well, I know 25 goes into 104 times, so it would go into 624 times, and then there'd be 75 left over. That'd be 3 more, so that'd be 27 times. Oops, sorry for the color change there. Or you could just do this and divide it out and figure that out. So now I have my simplest form of that. So I have 9 and 27/40 would be that decimal number in simplest form. Today you'll be asked to write a repeating number as a fraction in simplest form. Now this can seem a little confusing, but once you get the hang of it, it's going to make more sense. So you'll want to use this page here, or this part right here, as you get to that part in your assignment to make sure you go through the steps correctly. So the first thing we're going to do is we're going to let n represent the repeating decimal there. So 6/10 repeating would look like this, and then I just put the dot to show that it keeps on going forever. Our next step for this one is to multiply each of the sides by 10. Okay, so you can see they've multiplied each side by 10. Remember, if I multiply both sides by 10, they're still the same value, as long as I do the same to both sides. So these would still be equal. Now the reason I multiplied by 10 is because I want to get whatever repeats as a whole number. So when I multiply by 10, I move the decimal place one place to the right. So you can see that's been done right here. So now on this side I have 10n, and that's going to equal 6.666666 repeating. The next thing I'm going to do is subtract n, and they don't show this very well in this, but I'm going to subtract n from both sides. And the reason I'm going to do that is because I want to get rid of the 0.6 repeating. Okay? So I subtract 1n from the left-hand side. So I had 10n, I take 1n away, and I'm left with 9n. And because I subtracted n from the left-hand side, I also need to subtract n from the right-hand side. And remember, n equals the 0.666666 repeating. So if I subtract that, I'm getting rid of the 0.6 repeating from this side. So now I don't have 6.6 repeating on this side, I just have 6. So you can see that's shown right here. Now I'm left with 9n equals 6. The last step is to divide each side by 9. And that way, if I divide by 9, I get n by itself. So I divide 9 divided by 9, it cancels out. And I have now this divided by 9. And so I'm left with my fraction 6/9, or when I simplify that, 2/3. So the fraction for 6/10 repeating would be 2/3. And if you checked it on a calculator, this is what you would end up seeing. So this process will work for any repeating decimal. The only change would be if you have something like this where it is 42/100 repeating. Now instead of multiplying by 10, you'd have to multiply by 100 because we want to get the decimal to move 2 places so that the part that's repeating is a whole number. So if I had a 3-digit repeating number, I'd have to times it by 1,000 on each side so that the decimal would move 3 places to the right. The last thing we're going to do is we're going to identify and classify rational numbers. Now, the first thing we need to know is the difference between what are called irrational numbers and rational numbers. Rational numbers can be written either as terminating decimals, so decimals that end, or repeating decimals, like 0.6 repeating. Those would be considered rational numbers. Irrational numbers are numbers like pi is an example of an irrational number, where the digits 3.1415 continue on and on and on, and they don't repeat. Or here's another example of an irrational number, where the same block of digits, they don't repeat. So 7, 8, it's not 7, 8 repeating. You see each block of digits, it's different. It's going to continue that way forever, so we can't write it as a fraction. And so those would be considered irrational numbers. Today you'll be asked to identify all sets to which each number belongs. So let's say we have 2 here. Okay. First thing we want to do is figure out, is it rational or is it irrational? Okay, and 2 I know is a rational number. Okay, so that's one of the sets it will fall into. Okay, because it's a number that can be written as a fraction. So I would write rational number. It's also a whole number. Okay, 0, 1, 2, starting at 0, whole numbers. So yeah, that would be a whole number. And it's also an integer, because all whole numbers are also integers. Okay, so this would actually fall into 3 categories.